Welcome to the project demonstration of non-conventional electrical vehicle charging station by using solar and wind. So here we are using solar and wind for charging of a battery here, which is the charging station presents, and the output of this battery pack will be given as input to the electrical vehicle charging system. So we have developed a charging station, and this output is nothing but we can connect these cables to the electrical vehicle for charging purpose. So the process is from the solar and the wind, so which is the renewable sources, are used to charging of this battery pack. And whenever the unseason, like whenever this source is not providing the power supply to charging of the battery pack due to the unseason, nothing but rainy season or during the nights, so if you want to charge this battery pack using the backup source, that is from the grid. So from the grid we can charge this battery pack. So just once we connect that, we can see the light indication from the grid, and this is solar, as due to the low lighting on the solar panel we are getting the low intensity. Same for the wind also, so you can see the wind LED indication. So we are using the rectifier circuits, so in bidirectional, so clockwise or counterclockwise it will rectify that to the battery pack for charging purpose. So either from the any one of the source, for example if we want to charge a battery either from the grid or solar or wind, so it will take around 5 to 6 hours continuously, constant current, constant voltage available, then you will get 5 to 6 hours to be fully charged. So if the three sources available at a time directly to this battery pack, so it will get charged in duration of only 1 hour, as we are getting the maximum power from these three sources, that is the solar and the wind and grid. Okay, coming to the ratings, so we are using 12 volt 5 watt solar panel, 12 volt 20 watt wind, and 12 volt 15 watts is a grid. So these three are the power ratings for the input sources, and the battery ratings is 12 volt 2 amp battery pack we are using. So in this battery pack we can observe 6 batteries are connected, in that these three are in series, these three are in series. So we'll get 12 volt 1 amp DC output from this battery pack, and from this battery pack 12 volt 1 amp, these two are in parallel, so we'll get 12 volt 2 amp DC output. So this is the charging for the battery pack from the sources to this storage device. Then after, based on the electrical vehicle battery ratings, we can decide this load. So the load is nothing but AC load. So here this 12 volts 2 amps can be boosted up to the 50 volts. If we are using the 48 volts battery pack, then we need to boost up this to the 60 volts maximum, and if you use the 100 volts of battery pack, then we need to use the 120 volts of DC output for the battery pack charging purpose. So for that purpose we are using this boost converter with help of full bridge, H bridge inverter circuits and step up transformer, and from there to the AC to DC converter. So here the stages is like DC to DC converter to charge a battery pack, and DC to AC converter with help of this H bridge inverter circuits, and AC to AC step up with help of this step up transformer, again AC to DC with help of this rectifier IC to provide the sufficient voltage to the battery pack. So that can be monitored on this multimeter, which can be getting the measuring of this output voltage from this AC to DC converter. So these are the stages in this, as we discussed the charging station. And then after this, the MOSFET H bridge circuit, a full bridge inverter circuit, which is used to convert the DC 12 volts 2 amps to the AC 12 volts 2 amps, and that will be step up to the 230 volts AC, and from there based on this load the voltage will be regulated output of this rectifier circuits. So if it is a higher load, we'll get the lower voltage. If it is the lower voltage, lower load, then we get the higher DC voltage from these slots. So this microcontroller used to provide the 50 Hz of pulses to the H bridge to convert the DC to AC from this H bridge circuit. So this is the power flow, so from the renewable sources and from the grid to the battery pack through these three charging circuits. So each charging circuit we can see the rectifier, filter and regulator. So when we provide the AC, this will act as a rectifier. When we provide the solar panel to this charging circuits, these four diodes will acting as a polarity correctors. So when we place the solar panel in reverse direction also, these diodes will rectify that, plus to plus, minus to minus. And in this one, these four diodes will acting as a correction of polarity based on the wind direction. So if we rotate in counterclockwise also, then that will be rectified with help of these four diodes. And this is a H bridge which is using the MOSFETs of IRF 540 and IRF 9540, which is the N channel and P channel MOSFETs to make the full bridge inverter circuits. and transformer, and this is the step up transformer, this is a step down transformer for charging purpose. So the output of the HBH 12 volts AC will be step up to the 230 volts AC. So this is the total section of this project to make the EV charging station. So let us check the demonstration. So when we on this, so after this light on and off 2 times, we can see the bulb got switched on. You can see this off, right, the bulb got switched on as to make the output voltage less. Then we can get the DC voltage. So you can see, so when we have this, the output voltage is 0. When we on this, so we're getting up to the 60 volts, so which is sufficient to charge a battery pack of 48 volts. Right. Thank you.